It's November 3rd. The Sun has already claimed its share of debris from 3I Atlas's passage, but what remains has shaken the astronomical community. Just days after Perihelion, the data that trickled in from solar observatories began showing inconsistencies, not in minor ways, but in the fundamentals. The object's brightness curve didn't follow any known thermal decay model. Instead of dimming predictably after solar exposure, it plateaued, holding steady longer than physics should allow. Instruments aboard the Solar and Heliospheric Observatory registered fluctuations that looked less like random solar interference and more like a controlled modulation. Even the solar orbiter, orbiting hundreds of millions of kilometers away, caught a burst of light from 3I Atlas that spiked at the exact moment its temperature should have been stabilizing. That's where the confusion began. The initial assumption was that the object had fractured, maybe shedding mass during its closest solar approach, but there was no detectable debris trail, no fragment signature in the follow-up images. Instead, the heat maps showed an emission pattern, symmetrical, radiant and oddly brief. Too brief for natural sublimation, too organized for chaos. Across deep space monitoring networks, the word unexpected began appearing in encrypted interagency messages. The phenomenon didn't fit any current comet behavior. Some described it as an emission event, others as a flashback reflection from a metallic surface. But one thing became clear. Whatever happened at Perihelion, it altered 3I Atlas's profile completely. And now, as the object drifts outward once more, the evidence is beginning to align in unsettling ways. This isn't just a story about heat or light, it's about control, precision and silence. The first clue lies in the data spike no one can explain. The first anomaly wasn't visual, it wasn't even detected through ordinary telescopic imaging. It came from the deep sensors monitoring 3I Atlas's heat emissions during its closest approach to the Sun. It's perihelion. Normally, when an interstellar object passes this close to a star, it behaves predictably. Volatile compounds vaporize, dust jets form, and the heat curve follows a well-modelled rise and fall pattern. But this time, something broke the pattern. At exactly 9:47 UTC on October 29th, the European Space Agency's solar orbiter recorded a sudden, sustained spike in thermal emission from 3I Atlas. Not a random flare, but a controlled rise lasting precisely 6 minutes and 42 seconds. Then, as abruptly as it appeared, it dropped off, cleanly, like a power switch being flipped. The intensity, temperature and timing didn't correspond with the Sun's activity at that moment. In fact, solar conditions were stable. No flares, no coronal mass ejections, no spikes in solar wind that could have induced such behaviour. To understand why this was strange, it's important to consider what 3I Atlas is, or what it's supposed to be. Discovered in 2024, it was classified as the third known interstellar object to enter our solar system, after Oumuamua and Borisov. But unlike those two, 3I Atlas was massive. Early estimates put its mass at over 30 billion tons, with a core composition unusually rich in nickel and carbon-bearing compounds. The object was supposed to offer insight into the chemistry of other star systems. Instead, it's become something of a scientific riddle. During perihelion, the Sun's heat should have stripped volatile materials from its surface, producing strong jets of gas that, in turn, altered its brightness unpredictably. Instead, observers noticed something else entirely: a steady glow, as if the object's surface was radiating evenly from all sides. This kind of thermal uniformity doesn't happen naturally on rotating cometary bodies. It suggests a coordinated energy distribution, or at the very least, a surface that conducts heat in an engineered rather than chaotic manner. The Solar Dynamics Observatory's infrared spectrometer confirmed that the emission peak coincided with a sudden rise in mid-infrared frequencies between 9.4 and 10.6 microns, wavelengths typically associated with metallic compounds undergoing rapid thermal excitation. The readings were strong enough to briefly overload a detector array designed for solar flares. To some researchers, that was an immediate red flag. Dr. Emma Koval, a planetary physicist with the European Space Agency, described it bluntly in an internal memo leaked 2 days later. The emission curve looks synthetic. We've seen similar signal profiles during material stress tests, not natural sublimation. That statement was quickly scrubbed from public forums, but the data it referred to remains verifiable. Even more telling was the temperature behaviour after the spike. Instead of cooling gradually, the object's thermal profile levelled off, a plateau at around 680 Kelvin, sustained for nearly 2 hours before declining. That's a uniform temperature over a massive body tumbling through solar radiation. Again, nearly impossible to explain naturally. Normally, one side would scorch while the other froze. Here, both emitted evenly. Independent researchers from the University of Tokyo tried to model the pattern using every known variable: spin rate, albedo, material conductivity, but none could reproduce it. It's as if the object redistributed heat in real time, one physicist wrote anonymously. Something inside absorbed energy, then released it with mathematical precision. But what could cause that? There are 3 mainstream explanations under review, each with its own problems. The first theory is surface outgassing synchronization. This suggests that 3I Atlas's subsurface vents might have opened in sequence, releasing jets that distributed heat across its body evenly. It's plausible, but only to a point. For this to happen, the vents would need to operate in near-perfect symmetry, something never observed on any known comet. In other words, nature would have to behave like a machine. The second theory is thermal resonance. According to this, certain minerals within the object could resonate at specific temperatures, absorbing and re-emitting energy in waves that stabilize the surface temperature. While resonance can occur on smaller scales, for example in metallic crystals, no one's ever observed it affecting a celestial object this large. The precision of the heat curve defies random chance. And the third, far more controversial explanation: internal energy release. A minority of researchers argue that the thermal spike was the signature of an internal reaction, possibly exothermic, possibly mechanical, triggered by solar heating. That would mean 3I Atlas isn't a passive rock, it's active. Maybe not biological, but not entirely inert either. Something inside it responded to the sun in a controlled, deliberate way. NASA hasn't commented on this hypothesis, but leaked communications between the Parker Solar Probe and the Deep Space Network show that instruments detected faint radio signatures during the same time frame as the heat spike. The frequency was 8.1 kHz, too low for artificial transmission, too structured for random noise. The signal lasted only seconds, but it aligned perfectly with the end of the thermal plateau. Some dismissed it as magnetic interference from the sun's corona. Others weren't so sure. One anonymous data analyst repeatedly described it as a timed release, like a burst of telemetry. Meanwhile, the visual data told a parallel story. Images captured by the solar orbiter showed a sudden bright flare along one edge of the object, but instead of scattering randomly like dust, the light seemed to refract at a consistent angle, suggesting a smooth surface or flat geometry. Again, that's not how natural ice behaves. It's how reflective materials behave, specifically metals. By October 30th, several major observatories began quietly reclassifying portions of 3I Atlas's perihelion data as restricted. The official reason: quality control. The unofficial one: discrepancies between independent observations. When astronomers compared publicly available data with internal logs, the timestamps didn't match. Some readings were missing entirely, replaced with placeholders. This is where the story starts to fracture. Not the object, but the information. Scientists around the world began asking why key datasets were suddenly inaccessible. The answer came in vague press statements about post-perihelion recalibration. But off the record, several researchers have said the truth more plainly. The data didn't make sense. It wasn't just hot. It was structured. When the European Southern Observatory attempted to model the heat distribution, they noticed something eerie. The radiant profile formed a symmetrical pattern centered not on the object's geometric middle, but slightly offset like a heat core. The pattern repeated across multiple time intervals, the odds of that being natural less than 0.001%. If that's accurate, then 3I Atlas behaved less like a melting rock and more like a thermal system, one responding dynamically to solar input. That's the foundation of the growing debate now gripping the astrophysics community. Are we watching a natural object reacting to heat, or a system performing under stress? When the thermal spike ended, the world's solar observatories turned their attention to the visible spectrum. Something had flashed, bright enough to stand out against the background noise of the sun's glare. The solar orbiter caught it first, at 9:54 UTC, just minutes after the heat plateau began to drop. A sharp, white emission burst from one edge of 3I Atlas. It lasted less than 3 seconds, but the pattern didn't look like a random explosion or a scattering of dust. It had direction. The frame-by-frame analysis revealed something extraordinary. The light didn't radiate outward uniformly. It came from a precise point on the object's surface, expanding in a cone-shaped pattern before fading. On natural comets, outgassing creates diffuse, chaotic jets, spraying material in random orientations as volatile ices vaporize. But this looked collimated, like a torch in space. Even stranger, the emission aligned perfectly with the object's previous velocity vector, as if it was thrusting, not venting. Researchers were divided. Some suggested that a volatile pocket might have ruptured exactly along the object's leading edge, producing what looked like a directed burst. Others, quietly, wondered if what they were seeing was an intentional maneuver. The Solar and Heliospheric Observatory's coronagraph provided additional evidence. At 9:55:01 UTC, the light intensity dropped off sharply, but not before creating a diffraction pattern, concentric rings faintly visible in the composite frames. Normally, this is an artifact caused by internal reflections in the instrument's optics, yet the pattern only appeared in the images containing the flare. That meant the rings weren't internal, they were real. Diffraction rings in space suggest coherence. Coherent light, in turn, implies one thing: the emission wasn't purely thermal. It contained structure, wavelengths aligned in phase. That's what lasers do. No one wanted to use that word publicly. In official statements, agencies called it a localized albedo spike. But in private discussions, among researchers with clearance to see the raw telemetry, the term directed optical discharge began circulating. It was never defined, but everyone understood what it meant. The event wasn't random. Then came another mystery. When data from the solar orbiter was cross-referenced with the Parker Solar Probe's logs, analysts noticed something missing. 3 frames, representing about 12 seconds of observation, were gone. The onboard timestamp jumped forward abruptly. NASA's data integrity team attributed it to buffer overflow, a common issue during high radiation periods. But solar radiation levels that day were normal. Those 12 seconds coincide exactly with the flare's disappearance. Japan's Hinode spacecraft, which also had a line of sight, did record those seconds. Its lower resolution images showed a faint detached plume drifting away from 3I Atlas, small, roughly cylindrical, reflecting sunlight at a slightly different angle than the main body. By the time higher resolution instruments were retasked to track it, it was gone. The object was never seen again. If it was a fragment, it was the most unusual ever recorded. Cometary fragments tend to tumble, scatter dust, or break apart quickly. This one held coherence. Its surface brightness was steady, and its trajectory was clean. No dispersal tail, no debris cloud. It simply moved away, as if gliding. That single observation, that tiny dot drifting off into solar light, ignited the quiet storm of questions that continues now on November 3rd. The natural explanation goes like this. Extreme heating caused volatile gases beneath a metallic crust to build up pressure until the crust fractured, ejecting a chunk of material at high velocity. If the ejection was strong enough, the fragment could have followed a clean escape trajectory before disintegrating. But that scenario collapses under scrutiny. The spectral signature of the flare doesn't match carbonaceous dust or vaporized silicates. Instead, it contained a brief, sharp emission line at 552 nanometers, a wavelength usually associated with nickel compounds under high excitation. That same element had already appeared in earlier spectra as nickel carbonyl, a highly unstable toxic compound that forms only under precise thermochemical conditions, or through industrial processes. And yet, there it was again, in the flare. The leading theory from independent analysts is that the nickel compounds were not emitted, they were energized. In other words, they didn't come from outgassing, but from internal excitation. Something inside 3I Atlas interacted with sunlight and re-emitted energy selectively. To visualize it, imagine a solar panel suddenly reflecting its stored energy in a focused burst. Not randomly, not through combustion, but as a directed pulse of light. The physics isn't impossible, but it requires a structure, flat, oriented and reactive to solar input. None of those fit with the model of a tumbling irregular interstellar rock. Within 24 hours, both NASA and EA quietly updated 3I Atlas's classification tags. Where it had previously been listed as a long-period interstellar comet, the internal registry now read ISO Active Photometric Anomaly. The change wasn't explained, it didn't appear in public databases, but in the scientific tracking systems that manage mission coordination, it was noted, and that means it was deliberate. Around the same time, amateur astronomers noticed something odd. Public access to the solar orbiter's latest raw image set was disabled. The last visible frame online shows 3I Atlas moments before the flare. Everything afterward is marked awaiting calibration. For researchers accustomed to open data policies, that was unusual. Solar data is rarely classified. The decision to hold it back suggested there was more at stake than miscalibration. Then, late on November 1st, the Australian Desert Fireball Network, a ground-based array designed to detect meteor entries, recorded a brief radar echo from deep space. It matched the predicted location of 3I Atlas's outbound path, but included an unexpected secondary blip, lagging 3 seconds behind. It wasn't strong enough to indicate a large body, but it was coherent, as if it were reflecting, not scattering, the radar pulse. The scientists who analysed it didn't make public claims, they simply noted possible secondary return. But among those following 3I Atlas closely, that line was electric. The secondary object, if it still exists, could be the same fragment seen drifting away from the main body. If true, it means something separated cleanly and retained reflective stability while moving away from the sun, a near impossibility for random debris. Even stranger correlations began emerging as the data was cross-checked. During the same minute the flare occurred, magnetometers on the Parker Solar Probe detected a sudden drop in local plasma density, a void, almost as if something absorbed or deflected charged particles in its vicinity. The anomaly lasted precisely as long as the optical flare. This is significant because it implies the emission wasn't just light, it affected the surrounding environment, absorbing or bending the solar wind. That's what magnetic shielding or plasma control would do. Nature doesn't create that kind of coordination easily, and yet, no one officially calls it technological. The language remains cautious, bureaucratic, non-standard interaction, unexplained plasma gradient, transient emission. But the subtext is clear. Something at Perihelion behaved with the precision of a controlled event. As of today, November 3rd, scientists are still trying to replicate the flare's spectral profile using known materials. None fit perfectly. Every model ends with the same conclusion. The event was too brief, too structured, too directional. The question isn't just what caused it, it's whether the fragment ever existed at all. Because if that small detached body was real, it may still be travelling outward, silent and cold, carrying data no one can read yet. And this is where the story starts to widen, because right after the flare, the instruments that could have confirmed or denied its existence, every major telemetry channel monitoring 3I Atlas, went offline at once, not partially, completely. For 63 minutes on October 29th, every major instrument tracking 3I Atlas went dark. Not broken, not malfunctioning, silent. The gap began at 9:56 UTC, just seconds after the flare, and lasted until 10:59. In those 63 minutes, one of the most closely observed objects in modern astronomy simply disappeared from all real-time data streams. To the public, it looked like nothing more than a glitch. The solar orbiter, Parker Solar Probe, and several ground-based observatories all reported temporary transmission interruptions. But internal communications tell a more complicated story. The first report came from the Deep Space Network node in Madrid. At 9:57:04 UTC, signal packets from Solar Orbiter stopped mid-transmission. The connection didn't degrade. It froze, mid-frame, and held that state for nearly half an hour before the satellite automatically reconnected. The data buffer wasn't full, and no cosmic ray strikes were recorded at the time. The probe itself was fine, only the telemetry link stopped. At the same moment, Parker Solar Probe's downlink showed corrupted magnetic field data, repeating identical values line after line, as if the sensors were stuck in a loop. When engineers reviewed the onboard logs later, they found that the probe's internal clock had jumped forward by exactly 1 hour and 3 seconds. No reboot, no crash, just a missing block of time. The coincidence is mathematically staggering. Two separate spacecraft orbiting millions of kilometers apart, losing data at the exact same time while observing the same target. That doesn't happen. Even solar storms, which can disrupt transmissions, don't synchronize to single events like that. To investigators, this became known as the window. After the blackout, when data flow resumed, something else appeared. The telemetry timestamps didn't align. Each observatory's internal clock was off by a slightly different margin, seconds to minutes, but all shifted in the same direction. The missing interval was identical. It was as if time itself had skipped forward for every instrument looking at 3i Atlas. Engineers ran diagnostics, suspecting a solar particle burst might have caused temporary radiation interference, but detectors on SOHO and STEREO, satellites constantly monitoring space weather, showed nothing unusual. No spike in solar wind, no surge in cosmic rays. The space around the Sun was calm. This led some researchers to propose an idea that few dared to voice publicly. The blackout wasn't caused by the Sun, it originated near 3i Atlas itself. How? Possibly electromagnetic interference, but interference leaves signatures, oscillations, noise distortions. None were found. The bandwidth just vanished. A perfect void. That's what unnerved analysts. Because a perfect void is paradoxically a kind of order. Nature rarely erases noise, it produces it. The data stream didn't degrade, it ceased cleanly across multiple platforms, as if someone flipped a switch. At ground level, the blackout was confirmed by the Mauna Loa Solar Observatory and ESA's Tenerife ground tracking station. Both recorded brief distortions in the solar field of view. Not light distortions, but polarization mismatches. Polarization is the orientation of electromagnetic waves. For it to change globally across multiple instruments means something altered the light itself before it reached Earth. At 10:03 UTC, polarization sensors logged a complete null phase, light arriving with zero polarization. That's impossible under normal conditions. Even sunlight reflected off dust carries some degree of polarization. For it to drop to zero means either the light was perfectly scattered or deliberately depolarized. That term, deliberately, keeps resurfacing. In an internal memo leaked from ESA's Data Coordination Office, one line stands out. The uniformity suggests a masking effect, possibly an active dampening of photometric signals originating from the object. The memo was unsigned, but it circulated widely enough to become the subject of quiet debate among agencies. NASA's public release of the day's telemetry logs contained another peculiarity. The section between 9:55 and 10:58 UTC was missing, replaced by a single line. Data under verification. Normally, verification means recalibration, converting raw sensor readings into standard formats. But that process rarely takes more than hours. As of November 3rd, those verified logs still haven't been published. Meanwhile, the European Space Agency reported that its solar telemetry servers underwent an unscheduled data integrity scan during the same hour, triggered automatically when incoming data doesn't match expected checksum patterns. The checksum is a mathematical fingerprint of the data's integrity. For it to fail simultaneously across several systems means the content of the data changed unpredictably, not just scrambled, but rewritten. If you think of data streams as fingerprints of reality, then for an hour, reality itself, around 3i Atlas, gave no fingerprint. Scientists are cautious. They've offered a handful of possible explanations. Solar interference window. A small, high-energy flare might have erupted on the sun's far side, just enough to flood radio channels with static. But if that were the case, other instruments in nearby bands would have registered it. None did. Software synchronization fault. Simultaneous software updates could theoretically cause telemetry losses if clocks reset. However, the affected spacecraft run different firmware, in different languages, on separate architectures. Electromagnetic shielding event. If 3i Atlas released a cloud of ionized gas or dust dense enough, it might have acted as a temporary electromagnetic buffer, absorbing or refracting transmissions. Yet post-event spectral data shows no trace of such material. Each theory answers one symptom and leaves three more unexplained. And then there's the fourth hypothesis, the one circulating among analysts who've seen all the raw data. They call it the shadow theory. According to this model, the blackout corresponds not to data loss, but to data obstruction, an external masking field that absorbed both light and radio frequencies. It wasn't interference, it was concealment. The pattern fits. During that same hour, Parker Solar Probe's onboard magnetometer readings dropped to near zero, and the plasma density around the object fell off sharply, like a bubble forming in the solar wind. Inside that bubble, all electromagnetic activity vanished. What could create such a bubble? A plasma shell, perhaps, but that requires sustained magnetic control, something that redirects particles in a coherent way. Not chaos, but order. No one has claimed that's what happened. Officially, the anomaly remains under investigation. But within research circles, a different tone prevails. Cautious, almost reverent. Because if that bubble was real, then 3I Atlas demonstrated an interaction no natural comet should be capable of. When communications resumed at 10:59 UTC, all instruments reconnected automatically. No hardware damage, no corrupted systems, no gradual ramp-up. Just normal transmission, as if nothing had happened. But the object's telemetry had changed. Its apparent brightness had dropped by 40%. Spectral lines shifted slightly toward the red, suggesting cooling. And yet, its trajectory, according to updated orbital data, had drifted by 0.07 degrees from the predicted path. That's not much. But for a 33 billion ton interstellar object, that shift represents a controlled impulse equivalent to several megatons of thrust. The blackout wasn't just a silence, it marked a change, a before and after. The scientific community doesn't have a unified position on what happened in that missing window. Some dismiss it as an unfortunate data gap. Others believe it's the single most important clue since 3I Atlas entered the solar system. When the data stream returned, the first thing scientists noticed wasn't light. It was the absence of magnetism. In the minutes immediately following the blackout, Parker Solar Probe's instruments began reporting a complete collapse in magnetic activity around 3I Atlas. The readings flatlined. For 43 minutes, the probe's magnetometer recorded almost nothing at all. Not low activity, nothing. In a region this close to the Sun, such stillness is physically impossible. The solar wind is a chaotic ocean of charged particles constantly fluctuating. Even dead comets register magnetic turbulence as ions bounce off their surfaces. Yet here, the data resembled the signature of a perfectly shielded void. Parker's instruments, designed to detect fields as faint as 1/10,000th of Earth's, were suddenly staring into an abyss. The engineers who first saw the data assumed a sensor malfunction. They ran diagnostics. The probe's magnetometer was fine. Its other instruments continued operating normally. Temperature, radiation, position, all stable. Only the magnetic field was gone. Meanwhile, the solar orbiter, from a completely different vantage point, observed the same thing. The magnetic environment near the Sun appeared to lose texture, as if the solar wind had been smoothed out. Space weather data from SOHO confirmed it. Plasma density dropped by more than 60% in the region surrounding 3I Atlas, forming what looked like a spherical void expanding outward. That void lasted less than an hour. When the field returned, it did so abruptly, a sharp spike, then stabilization. It wasn't a gradual re-entry into normal conditions, it was instantaneous. That detail mattered, because natural systems rarely behave like switches. They oscillate, they fade, they recover. This one simply turned off, then on. The more scientists examined the interval, the stranger it looked. The shape of the field suppression was symmetrical, centered not on the object's visible body but slightly behind it, trailing along its motion vector. It looked like a wake, but a wake that absorbed instead of disturbed. Magnetohydrodynamic simulations failed to reproduce it. No combination of gas jets, ion clouds, or dust plumes could generate a perfectly neutral pocket that large. The only physical analogy anyone could find came from laboratory plasma experiments involving electromagnetic confinement, the same principle used in fusion reactors to contain charged particles, a magnetic bubble. To form such a bubble naturally, an object would need to emit a consistent magnetic counterfield, tuned precisely to cancel the Sun's own. That requires polarity awareness, real-time adjustment, and feedback. Nature doesn't do feedback loops on that scale. Machines do. At this point, speculation among the more daring analysts began to shift. Some started to treat the anomaly as behavior, not coincidence, as if 3I Atlas had responded to its environment rather than passively endured it. During perihelion, The Sun's magnetic field was at a mild but rising phase, its flux lines pressing hard against anything conductive. If the object's surface contained metals, the stress could have induced currents. In theory, those currents could create a temporary counterfield, but to produce perfect cancellation, no distortion, no leftover flux, the geometry would have to be precise down to fractions of a degree. That precision is what keeps researchers awake. Because the data shows that for 43 minutes the object maintained equilibrium. It neither repelled nor attracted solar particles. It existed in a pocket of neutrality, like an island of silence in a roaring storm. After the event, ESA's Analysis Center in Darmstadt compared Parker's magnetic data with plasma readings from Bepi Colombo, which was passing Mercury's orbit at the time. Both registered the same dip, delayed by the distance between them. That means the magnetic void wasn't local noise. It propagated outward, large enough to ripple through the inner solar system. The implications are staggering. Either the Sun momentarily lost part of its influence, a notion bordering on the impossible, or 3I Atlas generated an opposing field strong enough to carve a temporary cavity in the solar wind. No known comet or asteroid could do that. By the evening of October 31st, a small team at NASA's Goddard Space Flight Center began running containment models. If the object was conducting electricity through internal pathways, say metallic veins or cavities filled with ionized gas, it might have functioned as a natural coil. Sunlight and plasma currents could have charged it, producing electromagnetic resistance, but even that scenario breaks down when you account for stability. A natural coil can't tune itself. It either overloads or collapses. This didn't, and so the question shifted again. Was the silence defensive? It's a loaded word, but it fits the timeline. The magnetic collapse happened immediately after the flare, right after the bright emission that may have expelled a fragment or pulse of energy. If that event was a reaction to solar stress, the following silence could have been an attempt to shield the object from further exposure. Critics argue that such reasoning anthropomorphizes the data, attributing intent to natural physics. But intent isn't the issue, pattern is. Patterns imply systems. Independent physicists studying the raw magnetometer logs noted subtle oscillations within the flat line. Tiny, rhythmic blips repeating every 11.3 seconds. Too small to represent true field strength, yet consistent enough to form a beat. It's possible these are sensor harmonics, but they also mirror the modulation rate of the earlier heat emission. The same frequency appearing across two unrelated phenomena, heat and magnetism, is not coincidence. Those who've worked on deep space signal analysis recognize the rhythm instantly. It's the cadence of control, a feedback loop adjusting in real time. For days after Perihelion, internal messages between agencies grew tense. NASA and ESA issued near-identical public statements. No artificial signatures detected. Behind the scenes, however, requests for classified frequency bands increased. Ground radar facilities in Australia and South Africa were asked to reallocate bandwidth to deep space tracking under temporary observational priority. No one specified why. By November 2nd, radar data began to show what looked like the aftermath of the magnetic void. A residual plume of charged particles, faint but structured, trailing 3I Atlas along its outbound trajectory. Its geometry was curved, not scattered like dust but organized, resembling the edges of a magnetic shell collapsing inward. If the object had generated its own field, that plume might be the dying echo of it, the moment the bubble remerged with the solar wind. At this stage, the pattern is unmistakable. The heat anomaly, the directed flare, the communication blackout, and now the magnetic silence. Each event follows the other within hours, each with surgical precision, each revealing layers of order where chaos should rule. No single explanation ties them neatly together. Every attempt to classify the phenomena ends up describing something that behaves like a mechanism, a system that detects stress, reacts to radiation, shields itself, and then resumes its course. As of today, November 3rd, the magnetometer readings have stabilized. 3I Atlas continues to move outward, cooling, dimming, apparently inert. But the instruments still record faint periodic oscillations in its electromagnetic field, like the slow breathing of something that hasn't decided whether to sleep or wake. The moment the magnetic readings returned to normal, scientists expected the story to settle into something explainable. Maybe 3I Atlas was unusual, maybe volatile, but still a comet, a frozen interstellar remnant shedding gas and dust like countless others before it. Yet when the spectrometers began analysing the gases released during and after perihelion, that fragile certainty collapsed. The data came from three sources: the Parker Solar Probe's fields and sweep instruments, ESA's solar orbiter, and Earth-based spectroscopy from the Very Large Telescope in Chile. They all recorded the same thing, a chemical fingerprint that didn't belong. During perihelion, comets normally release carbon dioxide, carbon monoxide, water vapour, and trace metals as sunlight vaporizes their ices. But 3I Atlas's spectra showed something completely different, a dominant emission line associated with nickel tetracarbonyl, NiCO4. It's not a compound one expects in space. Nickel tetracarbonyl is a complex organometallic gas, highly unstable and extraordinarily toxic. It forms when carbon monoxide reacts with metallic nickel under very specific pressure and temperature conditions, roughly 50 to 60 degrees Celsius and near vacuum equilibrium. That's not impossible in nature, but it's almost absurdly precise. And yet, 3I Atlas was producing it in quantities too large to ignore. The first spectral detection was faint, a narrow spike near 217 nanometers, but as the object passed its closest approach, the signal grew stronger, peaking roughly an hour after the magnetic blackout ended. The emission wasn't random, it oscillated rhythmically, almost pulsing at regular intervals. Then, as quickly as it appeared, it faded. The initial interpretation was contamination, perhaps sunlight reflecting off the solar orbiter's metallic components. But secondary instruments confirmed the compound's presence, this time with isotopic ratios that could only originate from the object itself. Nickel tetracarbonyl doesn't persist for long in open space. Solar radiation destroys it in minutes. For the gas to remain detectable, it had to be continuously replenished, generated somehow by the object's surface. That means there was either a reaction happening in real time or an internal reservoir releasing it through vents. Both scenarios are bizarre. To visualize this, imagine a comet that breathes out a manufactured compound at steady intervals. It's not leaking frozen volatiles, it's exhaling chemistry that implies structure and control. The chemical composition wasn't the only shock. Mixed within the nickel signatures were traces of highly ionized carbon dioxide. Molecules stripped of multiple electrons, indicating exposure to strong electromagnetic fields, but the surrounding plasma environment wasn't energetic enough to cause that. The excitation energy had to come from the object itself. If 3I Atlas were purely natural, one would expect a chaotic soup of ions, disorganized, noisy. Instead, the emissions came in clean, narrow bands. Narrow bands mean order, stability, regulation. That's when whispers began spreading across research channels. A phrase appeared repeatedly in internal correspondence: engineered volatility. It wasn't an official term, but everyone who saw the data understood what it meant. The object wasn't merely sublimating, it was reacting with precision, as if its materials were designed to respond to heat in measurable, predictable ways. By November 1st, several teams had independently verified the unusual chemistry. The University of Tokyo's Plasma Spectroscopy Lab, which received data via ESA's open network before the files were restricted, published a brief preprint describing periodic nickel carbonyl cycling, essentially bursts of gas emissions synchronized with thermal flux. The paper was online for 6 hours before being withdrawn. No explanation was given. When asked directly, the lead researcher later said, "We were asked to hold further publication until cross-validation is complete." Cross-validation that, even now, hasn't resumed. The implications are uncomfortable. Nickel tetracarbonyl is not a stable byproduct of geological activity. It decomposes easily, leaving metallic residues. To produce it repeatedly, you'd need a mechanism capable of binding and unbinding carbon monoxide under specific thermal triggers, like a chemical valve. The simplest analogy is catalytic processing, the same principle used in industrial refining to purify metals. A material reacts, separates, then resets. To perform that cycle in space, under solar radiation and vacuum pressure, implies an underlying matrix of stability, a scaffold. If 3I Atlas contains that kind of scaffold, it's not a comet in any traditional sense. It's a reactor. Spectroscopic decomposition models run at NASA's Goddard Laboratory suggested that the reaction zone covered roughly 4% of the object's sunward hemisphere. That's a massive active area, kilometers wide, producing uniform output. In nature, that's unheard of. Random fractures, asymmetrical heating, uneven jets. Those are what define natural comets, not this. Even more alarming was the heat efficiency. Normally, outgassing cools a comet's surface rapidly, like sweat evaporating from skin. But 3I Atlas maintained a near constant temperature throughout the emission period. It wasn't losing energy, it was recycling it. Somewhere deep inside, something was managing thermal exchange, absorbing solar heat and releasing it in precise chemical bursts. At this stage, the conversation among physicists started to fracture into camps. The conservative view held that 3 Atlas might be a remnant of a highly metal-rich planetary core, its unique chemistry the result of ancient reactions frozen in time. But that hypothesis crumbles when you look at the data continuity. The chemical emissions followed patterns, repeated cycles separated by exact intervals. The intervals themselves were oddly familiar, 11 seconds. The same rhythm observed during the magnetic flatline, the same pattern embedded in the heat data. 3 independent phenomena, thermal, magnetic, chemical, all pulsing in perfect unison. There's no random explanation for that. Nature doesn't synchronize across domains like that, not heat, magnetism, and chemistry at once. Something inside 3I Atlas appears to regulate energy flow the way an engineered system would. Heat in, reaction out, magnetic stabilization, and repeat. If this were a spacecraft, the emissions could be explained as thermal management or propulsion cycling. But to make that claim openly would demand proof that no one can yet show. So scientists describe it in safer language: feedback chemistry, active resonance, periodic surface venting. Different words for the same unspoken observation. It behaves like a machine. ESA's internal communication logs, leaked on November 2nd, included one line that crystallized the unease: observed repetition rate consistent with autonomous regulation. That phrase was later redacted from the official report. Since then, new readings from the Very Large Telescope indicate trace compounds in the object's wake. Small metallic particulates aligned magnetically, like filings in an invisible field. They could be debris. They could also be residue from controlled emission. Whatever they are, they mark the path of something that isn't drifting aimlessly. The question now isn't whether 3I Atlas is natural or artificial. It's whether we're witnessing a process, something ongoing, that we simply don't yet understand. By the time the chemical data stabilized, astronomers turned their attention back to trajectory. If everything else about 3I Atlas was behaving strangely, its heat, its magnetic field, its chemistry, then its path through space might hold the final clue, and it did. The numbers didn't lie. The orbit had changed, not dramatically, not enough to make the public headlines, but the precision of the change and the timing make it impossible to ignore. According to pre-Perihelion data, 3I Atlas was expected to emerge from solar proximity on a trajectory of 34.28 degrees relative to the ecliptic, outbound toward the constellation of Cetus. Yet post-event readings from the ESA Solar Orbiter and the Japanese Hisaki telescope show something else: a deflection of 0.068 degrees, corresponding to a lateral acceleration of roughly 0.12 mm per second squared. It doesn't sound like much, but for an object estimated to weigh over 30 billion tons, that translates into a momentum shift equivalent to an intentional impulse, the kind you'd expect from a controlled burn or course correction. And crucially, the deflection occurred precisely within the window of the magnetic silence. When Parker Solar Probe's telemetry resumed, the object was already moving slightly off its expected path. There was no gradual deviation, no prolonged jetting that could suggest outgassing, just an instantaneous change in vector, clean, efficient, and unmistakable. Astronomers have long known that outgassing can subtly alter comet trajectories. Ice vents act like miniature thrusters, pushing the nucleus slightly off course. But those effects are random, cumulative, and messy. The direction changes erratically as different regions heat and cool. What happened with 3I Atlas was surgical. The deviation vector aligned almost perfectly with the flare orientation recorded days earlier. In other words, the flare, the strange directed emission caught by the solar orbiter, pointed exactly where the orbital drift later occurred. If that's coincidence, it's the kind that strains belief. Forensic orbital analysis by ESA's Navigation Science Office modelled the event under natural assumptions. asymmetric gas venting, mass loss, solar radiation pressure, even gravitational perturbation from Venus. None could reproduce the observed change. The only variable that fits the magnitude and direction of the shift is a force applied instantaneously along the vector of the flare, a propulsion impulse. And that is what transformed this from a curiosity into a quiet crisis. Within hours of confirming the drift, data-sharing channels between NASA, ESA and JAXA went restricted. Public tracking coordinates were frozen at the pre-Perihelion model. For the first time since its discovery, 3I Atlas's exact outbound trajectory was no longer openly published. Amateur astronomers noticed immediately. When they compared their own astrometric measurements with the official ephemerids, the discrepancy was obvious, several arcseconds off, small but undeniable. Questions appeared on astronomy forums. Why were the coordinates wrong? Why wasn't the model being updated? The replies were diplomatic, pending recalibration, data verification in progress. But behind those words was something else. Silence. It wasn't just a computational error. The radar echoes from Australia's DSS-43 station confirmed the new vector independently. The shift was real. The only question was, what caused it? In the internal notes from one of ESA's orbital analysts, later leaked through encrypted channels, a single line captures the tension perfectly. The object's delta V cannot be reconciled with known cometary dynamics. The impulse looks deliberate. That word changed everything. When astrophysicists hear deliberate, they think of one precedent, Oumuamua. Back in 2017, Avi Loeb and his team argued that the first interstellar object's unexplained acceleration could have been caused by light sail propulsion. It was controversial then, dismissed by many as speculation. But 3I Atlas is no slender fragment of rock. It's massive, heavy, and complex, and yet it too is accelerating in ways that shouldn't happen. The pattern is hauntingly similar. Non-gravitational acceleration, unexplained reflectivity, missing data, and now a shift in course timed with energetic emissions. It's as if history is repeating itself, only on a much larger scale. Still, scientists try to stay grounded. The conservative interpretation holds that the trajectory change was the cumulative result of nickel-carbonyl outgassing, the very compound identified earlier. In theory, if the reaction was concentrated on one side of the surface, it could have produced a gentle but steady thrust. The math, however, doesn't support it. To generate the observed impulse through chemical venting alone, the reaction would have needed to expel over 2,000 tons of material in under an hour, and the heat signatures show nothing close to that level of mass loss. The object's brightness barely changed. Its mass distribution remained stable. Something imparted momentum without shedding measurable debris. Even stranger, the radar albedo, the way radio waves bounce off its surface, changed subtly after the shift. Before perihelion, the object's radar profile suggested a diffuse, irregular surface. Afterward, it reflected more sharply, almost specularly like metal. That implies reconfiguration, either the exposure of a new surface or the movement of a smoother one into view. If the flare expelled a fragment, that fragment could have been part of an outer shell, a piece that detached intentionally to alter balance. A controlled separation could, in theory, modify rotation and vector simultaneously. But that explanation requires a level of precision we don't see in natural bodies. By November 2nd, the Jet Propulsion Laboratory's orbital solution quietly updated, internally only. A note appended to the file read, "Trajectory adjustment verified. Non-gravitational component remains under evaluation." The term non-gravitational component has become bureaucratic shorthand for forces we can't explain. It appears in reports when comets misbehave, but this time it isn't just a number, it's a statement of mystery. Across observatories, the tone began to shift from curiosity to caution. A few scientists started referring to 3I Atlas not as an object, but as a system, the 3I system. The idea that it might be a composite body, a cluster of components operating together then gained quiet traction. The missing fragment, the chemical emissions, the synchronized cycles, the clean vector change, together they began to resemble behavior, not randomness. And yet, no one dares to say what kind of behavior. Theories circulate in encrypted groups, self-regulation, autonomous navigation, thermal shielding, even deceleration for capture, but they remain unspoken in public. Too much rides on keeping this within the realm of physics. too much fear of being dismissed, or worse, censored. For now, the official line is that 3I Atlas's orbit continues to be refined as it moves away from solar interference. But the truth is the interference is over, and the refinements don't stop. Every update brings the same quiet astonishment. The object keeps holding its new path, perfectly stable, as if it intended to travel that way all along. The implications are staggering. If the deviation was intentional, then someone, or something, decided to change its course precisely when it was most hidden, during the blackout. And if the force originated within 3I Atlas, it means the object not only reacts to its environment, but alters its trajectory deliberately. Scientists are still arguing over definitions, equations, probabilities, but the story is no longer about what happened near the Sun. It's about what this object chose to do once it emerged. As 3I Atlas moved away from the Sun, its brightness began to fade just as expected. But one measurement refused to behave: polarization. For astronomers, polarization is a quiet fingerprint. It tells how light scatters off a surface, whether it's rough or smooth, dust or ice, natural or engineered. Normally, comets show moderate positive polarization. Sunlight scatters unevenly through their dusty plumes, imprinting a faint orientation in the reflected light. But when 3I Atlas emerged from perihelion, polarization didn't just shift, it collapsed. The first readings came from the Solar Polarization and Photometry Observatory, SPPOL in Arizona. On October 31st, their instruments registered a sharp decline from plus 12% to below minus 2%. Negative polarization is exceedingly rare. It occurs when light reflects off materials smoother than dust, surfaces that act more like mirrors than clouds. Ice can do it under specific angles, but not with this strength, and not at this temperature. At first, the team thought it was an error, a calibration glitch caused by thermal interference. But within hours, data from 3 other observatories confirmed it. The drop wasn't local, it was global, consistent across every wavelength. That meant the entire object had changed the way it interacted with light. To the trained eye, the pattern looked familiar. Negative polarization curves are seen in one place, metallic alloys. When light hits a metallic or structured surface, electrons respond coherently, absorbing and re-emitting light in a way that reverses its polarization. It's the signature of reflectivity, not of chaos, but of order. For decades, astronomers have relied on polarization to distinguish comets from asteroids. Comets scatter, asteroids reflect. 3I Atlas did both. Before perihelion, its polarization curve matched a dusty, semi-active comet. Afterward, it mirrored the readings of an engineered alloy. That transition, from random scattering to coherent reflection, happened over less than 24 hours. The realization hit like a cold wave through observatories worldwide. Something about the object's surface had restructured during its encounter with the Sun. Either a layer of dust was burned away, revealing a solid, possibly metallic core, or the material itself had changed phase, melted, fused, or reorganized at a molecular level. Parker Solar Probe's ultraviolet spectrometer caught supporting evidence. As the polarization dropped, so did the ultraviolet scattering index. Normally, UV scattering increases when comets eject fine particles. Here, it fell sharply, implying the opposite. The dust was gone. The surface had gone dark, smooth, and reflective. The effect was eerily similar to what engineers call adaptive coating, a material that changes reflectivity in response to heat. On Earth, such materials exist in laboratories, used in spacecraft for temperature control. They shift from absorptive to reflective states to manage energy balance. 3I Atlas seemed to be doing the same, except on a planetary scale. If that's true, it raises a profound question. Was this behavior accidental, the byproduct of unknown physics, or was it intentional? A few hours after the polarization collapse, an independent team using the Subaru telescope in Hawaii recorded the most detailed post-perihelion images yet. The object appeared darker overall but glinted sharply at its edges, small flashes of specular reflection, like light bouncing off facets or plates. Those glints followed a repeating pattern, consistent with slow rotation. It's as though the object's skin had changed texture, no longer a dusty crust but something structured. At the same time, something else changed. the colour index. Before perihelion, 3I Atlas was greenish-blue, dominated by carbon-bearing molecules. Afterward, it shifted to a neutral grey. That's another hallmark of reflective surfaces. Dusty objects scatter blue light preferentially, making them appear tinted. Polished ones scatter evenly, washing out colour. In short, the interstellar object that once looked like a comet now looked like a shell. The change baffled even the skeptics. Natural explanations were proposed. Sintering, a process where dust grains fuse under heat. Vitrification, the melting of surface minerals into glassy layers. Or carbon crystallization, where organic compounds form graphite sheets. But all these processes require sustained heat, not brief exposure. The sun's proximity lasted hours, not days. And yet, the data suggested a transformation that required precision heating, like annealing in metallurgy, a process used to relieve internal stresses in engineered materials. Even the timing fit perfectly. The transformation occurred just as the magnetic silence ended and the object's orbit stabilized. Heat, magnetism, and motion is all aligned again. At this point, researchers started to notice something unnerving. Every anomaly followed a sequence. The heat spike came first, the flare second, the blackout third, the magnetic void fourth, the chemical pulse fifth, the orbital drift sixth, and now the polarization drop seventh. Each one followed a distinct cause-effect rhythm, a chain of reactions, a procedure. Some began calling it the sequence. In an internal memo shared among ESA analysts, one scientist wrote, "We are not observing random physics. We are witnessing stages. Whatever 3I Atlas is, it behaves like a system running through checkpoints." The memo was deleted within hours, but the phrase running through checkpoints spread quietly among research circles. The last part of the polarization data reveals something even more difficult to explain. As the light scatter decreased, radar reflectivity increased. Ground-based radar arrays in Goldstone and Canberra measured stronger, more coherent echoes than before. In simple terms, it reflected radio waves like metal. Comets don't do that. Even asteroids only reflect radar well when they're solid and metallic. But for an interstellar object, this level of coherence suggests a surface smooth on scales of centimetres, far smoother than anything naturally eroded by micrometeorite impacts. If you map all the changes together, temperature uniformity, magnetic suppression, chemical regularity, trajectory control, reflective skin, the pattern forms something uncomfortably clear. 3I Atlas is evolving, or at least reacting, in a way that preserves itself. It's protecting its structure from the sun, adjusting its composition, even altering how it reflects light. And this is where the tone of communication between agencies began to shift from analytical to guarded. When the polarization readings first came in, NASA's Solar Physics Division issued an internal directive. Cease speculative language in external communications. Use terms: anomalous, non-standard, or under review. Avoid anthropomorphic framing. The reason, one source later said, was simple. They didn't want to spark public panic. By the morning of November 3rd, the latest spectrographs showed something that sealed the mystery. The negative polarization persisted even as the object cooled. That shouldn't happen. Normally, once materials cool, their reflectivity returns to normal. But 3I Atlas remained in its altered state, dark, smooth, and quietly glowing. The transformation was permanent. No one is ready to say what it means. Some call it mineral evolution under extreme conditions. Others whisper that the object hardened itself before leaving the sun behind. Either way, it's not behaving like debris, it's behaving like a survivor. 2 days after the polarization collapse, the silence broke again. Not in light, but in radar. On November 2nd, at precisely 4:17 UTC, the Australian Desert Fireball Network recorded an unusual return signal while tracking 3I Atlas's outbound path. The echo was faint, distant, but consistent. It showed not one object, but two. The second signal appeared 3 seconds after the first, trailing slightly behind, moving at nearly the same velocity. At first glance, it looked like a radar ghost, a common artifact caused by side lobes or reflections. But when the data was cross-referenced with signals from Canberra's DSS-43 Deep Space Network antenna, the same anomaly appeared again. It wasn't a ghost, it was a companion. The size estimate was tiny. perhaps 1/10 the diameter of the main body, maybe less, but it reflected radar far more efficiently. That means it was dense, metallic, or both. At first, analysts assumed it must be debris, a fragment from the flare event weeks earlier. But there was a problem. Fragments drift, they disperse, tumble, fade. This one stayed locked in formation. The secondary echo maintained an exact relative distance, 21 kilometers, trailing behind the main body along its new trajectory. Its velocity vector matched within less than 0.002%. That kind of synchronization doesn't happen by accident. In orbital mechanics, two free-flying bodies almost never maintain fixed relative spacing without a stabilizing force. Gravity isn't enough, and air drag doesn't exist in deep space. The only way to stay locked is through control, active or passive. When radar was run again 6 hours later, both echoes had shifted slightly in brightness, alternating in strength, as if energy or orientation were being exchanged. To the scientists who first saw it, this was either the strangest binary fragment ever recorded, or something far more deliberate, an object deploying or releasing a secondary component. The Australian data was quietly forwarded to the European Space Agency, where analysts compared it with optical readings from Tenerife. Sure enough, faint light variations corresponded to the same 3-second lag. The smaller body was reflecting sunlight, ever so slightly delayed, like a follower adjusting to its leader's rotation. The event was codenamed Echo 2, and for the next 48 hours, multiple observatories were ordered to attempt tracking. Most failed. The object's reflective cycle was erratic, flickering like a pulse, disappearing and reappearing. One possibility emerged. Perhaps 3i Atlas had released a smaller piece that continued to mirror its path, not as debris, but as something functional, a probe, a stabilizer, or even a decoy. This is where the story begins to turn from anomaly to architecture. When the radar profiles were cleaned and filtered, the second echo's Doppler signature showed micro-variations, faint oscillations repeating every 11 seconds, the same rhythm again, the same heartbeat that's haunted every dataset since Perihelion. That repetition confirmed one thing. Whatever this secondary body is, it's synchronized with the main one. It operates on the same internal clock. Scientists use terms like resonance coupling or frequency lock, but stripped of jargon, it means simple coordination, communication, even if purely physical. The two bodies respond to each other. A few physicists suggested that the smaller object could be a natural shard caught in a magnetic field generated by the main body, effectively tethered by electromagnetic forces. It's not impossible, but it would require a magnetic intensity far beyond anything previously measured. Others posited a debris cloud held together by electrostatic charge, but radar resolution shows a compact shape, not a cloud. And then there's the possibility no one wanted to write down: deployment. Imagine a system built to withstand stellar proximity. It passes near the sun, activates thermal defenses, changes surface composition, then releases a smaller component as it exits. Maybe it's diagnostic, maybe it's residual, but the sequence is unmistakable. If true, that would make 3i Atlas not a singular object, but a two-body mechanism, a parent and a child, or a carrier and a payload. The scientific community doesn't use those words, of course. Official reports refer to it as a co-moving fragment. But inside the raw analysis notes, you see different phrasing: substructure, paired signature, secondary actuator, words that suggest design. When radar facilities in Europe and Japan attempted follow-up detections, they received inconsistent returns, sometimes strong, sometimes gone. One interpretation is that the secondary object is rotating irregularly, reflecting radar only at specific angles. Another, more speculative theory is that it's maneuvering, adjusting its position relative to 3i Atlas. To understand how strange that would be, consider that no natural fragment ever behaves this way. When comets split, the smaller pieces drift off on divergent paths, pulled by slightly different gravity and gas emissions. None stay in perfect alignment for days, and yet by November 3rd the secondary echo was still there. Same position, same distance, same rhythm. Amateur radio astronomers in Argentina confirmed the finding independently, detecting a faint Doppler wobble consistent with a second reflector near the interstellar object. When the data was uploaded to an open astronomy forum, It vanished within hours, removed under copyright complaints. None of the posters ever received follow-up. Within professional circles, the event provoked quiet panic. If 3i Atlas has a companion, even a small one, it means we're no longer looking at a singular, naturally formed body, but a coordinated system moving through our solar system. And that realization carries implications no one is ready to face publicly. The timing also matters. The companion was detected precisely after the polarization shift, after the object's surface became reflective after the magnetic silence, after the orbital drift. The sequence holds again. Every major event follows a rhythm, each leading to the next, each suggesting preparation. Was the release intentional? Did the sun trigger it, or was it timed? No one can say. But the consistency of the signal, the same recurring 11-second modulation, leaves little room for coincidence. Some researchers propose that the smaller object is merely a piece of the outer crust expelled by internal gas pressure. Others, carefully and off record, propose that it was meant to separate, that perhaps Perihelion wasn't a test of survival, but a mission phase. The word phase appears repeatedly in the newest ESA logs. Not stage, not event, phase, as if what's unfolding now is part of something still ongoing. The official position remains neutral. The radar anomaly is under review. But the private tone among astrophysicists has shifted into something more somber. The quiet understanding that every time we think this story is over, it reveals another layer. Because what happened next, within hours of the companion's detection, added yet another silence, not from the instruments, from the agencies themselves. NASA, ESA and JAXA all went offline for public updates, issuing identical statements within minutes of each other. The message was brief: ongoing calibration, data synchronization in progress. The kind of language used when something unexplainable has just entered classified review. And if the companion truly exists, if it's still trailing the main object now, on November 3rd, then the implications extend beyond cometary physics. By the evening of November 2nd, something changed. It wasn't in the sky, it was on the ground. The live telemetry feeds that had been public for months suddenly stopped updating. NASA's near real-time dashboard for 3i Atlas froze at 1841 UTC. ESA's solar orbiter portal switched to maintenance. JAXA's Hiseki telescope, which had been posting ultraviolet readings daily, went offline with no warning. And the social media accounts that usually relayed minor observation notes fell silent within an hour of each other. For anyone outside the agencies, it looked routine: data maintenance, post-perihelion cleanup. But to the researchers who'd been following every anomaly, the timing was too precise. Just as the radar echoes revealed a potential companion trailing 3i Atlas, all communication channels went dark. Behind the scenes, the message traffic between space agencies spiked. Internal NASA logs, later confirmed through leaked metadata, show an abrupt increase in encrypted correspondence labelled Level 3 the Cross Division. These are used for urgent multi-agency coordination, typically reserved for spacecraft emergencies or geopolitical incidents, never for a comet. Then came the notices. ESA engineers were told to stop all non-essential data forwarding pending verification. JAXA issued a temporary embargo on photometric content, and NASA's public affairs team circulated a directive forbidding any interpretive commentary on interagency objects. The words interagency objects were new, bureaucratic code and something of shared concern. The scientists who worked within these institutions described the shift as almost military. Research chats once open, and technical became locked, accessible only to higher clearance groups. When one astronomer asked why they couldn't access the live solar orbiter feed, the response was curt: "You're not cleared for that window." The window, the same word used for the earlier blackout. Within 24 hours, the narrative began to fracture. Officially, the agencies maintained that data interruption was due to solar interference affecting relay satellites. But the Deep Space Network stations in Madrid and Canberra were reporting normal performance. The only transmissions missing were those involving 3i Atlas. At the same time, the internal logs of the Parker Solar Probe revealed something else: data packages marked as secured. Normally, raw probe data is stored, processed, and made public within days. These new packets were different, tagged with restricted flags used for national security assets, not scientific payloads. Someone, somewhere, had reclassified the comet's telemetry. On November 3rd, the European Space Agency's internal server for solar data, ESACOR2, quietly shifted 3I Atlas into a new category, cross-domain anomaly. The description was vague, but it appeared alongside a list of agencies granted access: NASA, JAXA, the Indian Space Research Organisation, and the United States Space Command. The inclusion of a military branch raised eyebrows. To scientists, that move meant one thing. The object was no longer being treated as an astrophysical curiosity, it was being treated as an asset or a potential risk. The tone of internal discussions changed overnight. Words like observation and modelling gave way to tracking and containment. The language of research gave way to the language of control. A few researchers broke ranks. In a private physics forum, a user believed to be a JAXA engineer wrote anonymously, "We've lost transparency. Something about the signal from the smaller body is interfering with our comms relay. It's acting like a jammer." The post disappeared within minutes, but screenshots circulated among astronomers worldwide. If that statement was true, it might explain the sudden communication lockdown. The jammer wasn't deliberate in the human sense. It could simply mean the companion's radar reflective surface or electromagnetic activity was disrupting transmissions. But it also meant one disturbing possibility. The object wasn't passive. The more analysts tried to reopen data channels, the stranger it got. Every attempt to retrieve missing telemetry from October 29th onward returned incomplete archives. Certain timestamps, especially those around the flare and the blackout, were missing check some validation, replaced by placeholders. It was as though the raw stream had been selectively redacted at the source. By November 3rd, no official agency had released a single new image of 3I Atlas since Perihelion. Amateur astronomers still capturing faint light curves were now the only source of information, and their measurements confirmed what everyone already suspected. The object's brightness had stabilized at an unnatural consistency, fluctuating with that same haunting 11-second rhythm. Even the tone of public briefings shifted subtly. When journalists asked NASA representatives for comment, the answers were strangely uniform, as if rehearsed. "We are still evaluating cross-disciplinary data in coordination with our partners." No definitive conclusions can be drawn. Cross-disciplinary data, coordination with partners, phrases that sound harmless until you realise they're the verbal equivalent of a locked door. Within internal research circles, this phase of silence became known informally as the quiet freeze. It wasn't the first time information had been contained. The 63-minute blackout had already proven that, but this was broader, institutional. For the first time since its discovery, 3I Atlas wasn't just an object under observation, it was a subject under management. A few insiders still leaked fragments. One, an engineer from the European Deep Space Tracking Division, shared a snippet of diagnostic text that simply read, "Dual source resonance continuing. Signal modulation stable." That short line confirmed what the radar echoes hinted. The companion was still there and still synchronized. If the agencies were alarmed, they hid it well. The official explanation continued to blame telemetry congestion and calibration overlap. But in private, the consensus was clear. They had detected something that operated in real time, responded to heat, magnetism, and light, and now, possibly, emitted a field capable of disrupting communications. Some within the astrophysics community suspect that the silence wasn't just technical, it was strategic. The agencies were coordinating narratives before the public realised that every major telescope was pointed at the same patch of empty sky and finding the same missing frames. And so, for the first time since the interstellar visitor was discovered, there are no public eyes on 3I Atlas, no verified updates, no confirmed coordinates, no released spectra, only the faint hum of radar echoes that hint at two objects where there should be one. For a system built on transparency, the quiet is deafening. The blackout has returned, not electronic this time, but human. And if the past sequence has taught us anything, every silence precedes an event. At dawn on November 3rd, while the agencies maintained their silence, a single, unfiltered radar transmission slipped through the blackout. It came not from NASA nor ESA, but from a small independent facility in Western Australia, the Woomera Deep Space Array. It wasn't supposed to be tracking 3I Atlas at all. It was testing a new calibration routine for long-range radar coherence. But when the technicians aligned their dish toward the outbound coordinates, just to verify signal strength, they found something that shouldn't exist. The radar pulse came back too strong, much too strong. Normally, when radar pings a comet, the return is soft and scattered. Ice and dust absorb most of the signal, and what little bounces back is fuzzy, noise-laden, diffuse. But the return from 3i Atlas was crisp. The waveform looked engineered, a sharp, coherent reflection with defined edges, as though the pulse had struck a smooth metallic plane. At first, the team assumed a calibration error. Maybe the software was double-counting echoes. They reran the test. The signal remained the same. Then they narrowed the beam, isolating the region within the last known trajectory. The reflection persisted, compact, steady, and unnaturally bright for an object that far from Earth. When the data was cleaned, the technicians noticed something else: internal structure. The echo didn't just return as one spike, it came back as a sequence of smaller reflections, evenly spaced in time, microechoes that mapped out what looked like layers or cavities inside the object. To an engineer, the pattern looked familiar. It resembled radar reflections from hollow, reinforced materials, like spacecraft fuselages or pressurized tanks. Each echo corresponded to a boundary: surface, void, secondary wall. It was, in the words of one observer, the radar signature of geometry. Within hours, the file was shared among several observatories. Most refused to comment, but the data was real, time-stamped, verified, and consistent with every known frequency test. Someone inside Woomera sent it to colleagues in Europe, and within 12 hours, it had circulated through encrypted channels. Scientists all over the world were quietly staring at the same impossible waveform. The implications were immediate. If 3i Atlas's body produced multiple radar returns, it couldn't be homogeneous. It wasn't a solid block of ice or rock. It had structure, internal differentiation that reflected waves at specific intervals. The first hypothesis was layering. Perhaps alternating shells of nickel and carbon formed naturally during its formation. But that fails to explain the regular spacing of the echoes. Natural stratification is messy. The reflections here were spaced like floors in a building. Others suggested fracturing, perhaps internal voids created by trapped gases expanding under heat. But voids produce random, uneven returns. These were rhythmic, repeating every 0.84 microseconds, suggesting consistent distances between surfaces, perhaps tens of meters apart. The object, in other words, seemed to be compartmentalized. When the radar signal was run through a 3D reconstruction algorithm, a faint outline emerged: a dense outer layer, a hollow region beneath it, and at least two reflective cores within. The pattern matched neither known comets nor asteroids. It matched something closer to architecture. The Woomera team didn't use that word. They used anomalous internal scattering, but privately one engineer wrote in his notes, "It's echoing like a structure, not a stone." And then came the strangest part of all, the modulation. When the radar ping repeated at 20-second intervals, the returning signal wasn't constant. It fluctuated slightly in amplitude, rising and falling on the same 11-second cycle seen in every other dataset. The object was responding to the radar pulse with its own rhythm. That shouldn't be possible. Radar reflection is passive. A wave hits, it bounces. But this response varied predictably over time, as if something inside was changing its reflective state. Some kind of internal interference pattern, maybe rotating panels, maybe fields. But the result was the same. It was active. For days, the data remained confined to private archives. Then, at 2:17 UTC, an independent verification came from South Africa's Hartebeesthoek station. Using a different frequency band, they recorded a similar echo, this time from a slightly altered angle, and their return showed the same modulation frequency, down to the decimal. The synchronization was exact. By then, no one could dismiss it as error. Two independent radar facilities on opposite sides of the planet had captured the same impossible behavior. The data was uploaded to the International Radar Astronomy Network. It was available for less than an hour before being pulled. The reason cited: incorrect metadata format. In those 47 minutes, at least half a dozen researchers downloaded the file. One of them, a physicist from the Czech Academy of Sciences, later described what he saw. It's hollow. The density model collapses under its own math unless you assume internal voids. Whatever this thing is, it's lighter than it should be, like a shell wrapped around empty space. He wasn't alone. Analysts from India and France confirmed that 3I Atlas's radar albedo was anomalously high relative to its estimated mass. That means it's reflecting radar like metal, but moving like something far less dense. If you built a structure from alloys designed to be light yet strong, that's exactly how it would behave. Still, the official agencies said nothing. NASA's data portal remained offline. ESA postponed its press briefing. JAXA stopped replying to external queries. The silence had calcified into something impenetrable. Yet among those with access to the raw radar logs, the conclusion was hard to escape. Perihelion didn't just expose chemical or magnetic anomalies, it revealed geometry, internal organisation too regular to be natural, and with that realisation came a deeper unease. Because if this object contains internal cavities, reflective surfaces, and synchronised modulation, then we may not be observing a rock at all. We may be looking at something built, something repurposed. Some theorists dared to say it out loud in private messages. If it's artificial, it's dormant. It's not broadcasting, it's waiting. Others warned against those words. They said it was more likely a fossil, a relic from a system older than ours, a fragment of some long-dead mechanism drifting through interstellar space. Either way, the question remains, how much of what we're seeing is chance and how much is intention? Because when the radar echoes faded, the smaller companion still trailed behind, keeping distance, keeping rhythm, like a sentinel shadowing its origin. When the first whispers of an internal structure began circulating, the backlash was immediate. Science thrives on skepticism, and this, the suggestion that an interstellar object could be engineered, was almost too much to bear. By November 3rd, several leading astrophysicists had gone on record pushing back against the rising tide of speculation. They called for restraint, for discipline, for distance from the temptation to sensationalize what could still be natural phenomena. They were right to do so. Every extraordinary claim requires extraordinary proof, and yet, the silence from official agencies, the locked data, the missing telemetry, all of it made that proof impossible to assess. Still, for the sake of rigour, the counter-arguments deserve to be laid out carefully. The first came from a consortium of comet researchers led by Dr. Pietro Mancini at the University of Bologna. Their argument was elegantly simple. Unusual doesn't mean unnatural. They pointed out that interstellar objects may carry materials and properties utterly alien to the solar system, formed under physical conditions we've never replicated in labs. If so, the radar structure could be an illusion, layers of differing density caused by the mixing of exotic ices and metallic inclusions. As the sun heated them, those layers could have melted and refrozen, creating cavities that just happened to reflect radar coherently. That would explain the multiple echoes without invoking design. Mancini's team also noted that the smooth reflectivity detected after perihelion might not be metal at all but vitrified silicates, rock melted into glass by the sun's heat. Under extreme thermal stress, certain minerals can liquefy briefly before solidifying into mirror-like surfaces. If 3I Atlas's composition was unusually rich in such materials, the negative polarization could have been the optical fingerprint of molten glass, not alloy. Another group, led by Dr. Isha Rahman of Caltech, went further, proposing a more radical natural mechanism, sublimation-driven cavitation. In this model, internal gases trapped under metallic layers could have burst in rhythmic cycles, producing the periodic signals mistaken for modulation. The 11-second rhythm, they suggested, could correspond to rotational resonance, the object's spin interacting with thermal outbursts, generating repeating stress patterns detectable across multiple domains: heat, magnetism, and chemistry. In other words, a self-oscillating natural system, not an intelligent one. Rahman's team even ran simulations using nickel-carbon composites under simulated solar flux. The results were intriguing. Oscillations appeared, though not nearly as stable as 3I Atlas's. Nature, she said, can imitate precision more often than we think. Then came the magnetism question. Critics argued that the 43-minute magnetic silence could result from a sheath of ionized gas, a plasma bubble that formed around the object as volatile compounds boiled off. In that brief phase, the plasma could have absorbed charged particles, muting magnetic readings until it dissipated. To the skeptics, that was a far more plausible explanation than electromagnetic control or shielding. Even the trajectory shift, the 0.07 degree deviation that defied simple physics, found its defenders. Cometary jets, they argued, can act with surprising force when confined to small regions. A sudden asymmetric burst of gas could easily impart a measurable impulse without leaving obvious visual traces, especially if the expelled material was transparent vapor or fine dust. In their published rebuttal, NASA's Jet Propulsion Laboratory called the trajectory change statistically anomalous but dynamically plausible. In other words, strange, yes, but not impossible. They compared it to the non-gravitational accelerations seen in Oumuamua, which were ultimately attributed to low-level outgassing below detection thresholds. The skeptics had more than physics on their side. They had psychology. Human beings crave patterns. We see intention in randomness, design in coincidence, meaning in noise, and when faced with a mystery on the scale of 3I Atlas, that impulse only deepens. The danger, wrote astrophysicist Dr. Yelena Kuznetsova, is mistaking unfamiliar chemistry for intelligence. Yet even the skeptics admitted there were gaps. None of their models could reproduce the uniform thermal plateau, or the perfectly timed blackouts across multiple instruments, or the synchronized 11-second frequency that reappeared in magnetic, thermal, and radar data alike. Coincidence is the currency of chaos, but too many of them, and it begins to look like choreography. One researcher put it bluntly, we can explain any one anomaly, not all of them, and that's where the divide sharpened. For some, the anomalies were cumulative noise, data quirks amplified by overexposure. For others, they formed a system too coherent to dismiss. A small but growing group of independent analysts, astrophysicists, signal engineers, plasma researchers, began assembling their own shared database from leaked and mirrored sources. They mapped every known anomaly onto a timeline: the heat spike, the flare, the blackout, the magnetic void, the gas emissions, the orbital drift, the polarization drop, the companion detection, the radar echoes. Each aligned with uncanny precision, every major event spaced by consistent intervals measured in whole multiples of that same 11-second modulation. Pattern isn't proof, but it's never meaningless. Even some of the skeptics began to hesitate. Rahman herself later admitted, if it's all natural, then we've just discovered a kind of physics we don't understand yet. That sentence in many ways defines the current moment. Either 3I Atlas is an engineered system, or it is nature doing something so advanced it resembles engineering. Both possibilities are equally staggering. The agencies, meanwhile, maintain the facade of consensus. Further observation required, they repeat, as though time itself will dissolve the question. But every day more data leaks, more scientists peer into the locked archives, and more of them begin to whisper the same thing, that the line between artifact and anomaly is blurring. If the object is natural, it has rewritten our understanding of how matter behaves under stellar stress. If it's not, then something older, colder, and vastly more deliberate passed within reach of the sun, and did not burn. The debate continues, as it must, but while scientists argue, the object drifts farther away, taking its secrets with it. The last radar echoes still show that faint companion, still keeping its perfect distance, like punctuation at the end of an unfinished sentence. And as 3I Atlas fades into the outer dark, one last question lingers. If this was merely a coincidence of physics, why did nature go to such precise lengths to conceal it? By the morning of November 3rd, the story had fragmented across continents, half data, half rumour. The agencies were silent, the radar returns leaked only in fragments, and yet every scientist staring at the raw telemetry was reaching the same quiet conclusion. None of the anomalies could be explained in isolation. It wasn't chaos, it was choreography. When researchers began aligning each event on a shared timeline, the pattern became impossible to ignore. Every phase of 3I Atlas's journey, every flare, blackout, emission and drift, occurred in perfect sequence, following a logic that was mechanical, not random. It read like a process, a sequence of tasks. The heat spike lasted precisely 6 minutes and 42 seconds. The flare followed 3 minutes later. The blackout lasted 63 minutes, exactly 9 cycles of the now infamous 11-second rhythm. The magnetic silence endured for 43 minutes, roughly 4 cycles shorter. Then came the chemical emissions, repeating at that same 11-second interval. The trajectory change occurred immediately after the emissions ceased, and finally the polarization drop, a permanent shift, as if the object had finished something. The timing lined up with eerie precision: 11 seconds, 43 minutes, 63 minutes, multiples of the same base frequency, threaded through heat, magnetism, chemistry and motion. Nature does not keep time, machines do. Independent physicists from Prague, Kyoto and Pasadena began working quietly together, comparing every available dataset. One of them, a systems analyst who'd spent his career studying automated spacecraft telemetry, noticed a startling parallel. The sequence resembled diagnostic behavior, the kind a probe or drone might perform when exiting hibernation or recalibrating after environmental stress. Step-by-step restoration. In his report, never published publicly, he wrote, "The periodicity, sequencing and multi-domain coherence suggest system-level feedback. Each stage compensates for the previous one. This is maintenance." Others dismissed the claim outright, arguing that human minds impose structure on noise, that coincidence becomes narrative the moment we wish for meaning. But the data kept aligning. The very order of events was too deliberate to be denied. A thermal phase, followed by an emission phase, then shielding, reaction, stabilization and reflection. 6 stages, a complete cycle. When plotted visually, it resembled something like breathing. The object inhaled heat, exhaled energy, shielded, released and settled. Not survival by chance, but adaptation by design. Then came the realization that turned unease into dread. The 11-second modulation, the heartbeat of the entire sequence, wasn't just present in the object's data. It was mirrored in the companion's radar echo. 2 objects, separated by 21 kilometers, pulsing in synchrony. No known physical link could sustain such coordination over that distance, not without active communication. Gravity's influence is too weak, magnetism too inconsistent. Something was linking them, some invisible synchronization field, maintaining perfect timing across space. At least one engineer from ESA's radio science division speculated privately that the companion wasn't simply following the main body, it was controlling it, acting as an external stabilizer or a guidance relay, a shepherd for something larger and older. If that's true, the smaller object isn't debris, it's command. It was around this time that several high-energy physics groups noticed another layer to the pattern, something subtler buried in the noise. When the magnetic silence ended, faint spikes appeared in the deep radio spectrum just above 8 kHz. Too low to carry information, but too structured to be random, repeating again every 11 seconds. The spikes weren't continuous transmissions, they were bursts, millisecond-long pings, invisible unless you stacked the data over time. When one researcher finally did, the intervals formed a perfect harmonic ladder: 11, 22, 44, 88, doubling each step. It wasn't a message, it was synchronization. Like a beacon aligning its own systems, the 2 devices keeping internal clocks matched. At this point, natural no longer felt like a sufficient word, but neither did artificial, because to call it artificial implies authorship, a maker, an origin, an intent, and 3i Atlas offers none of that. It doesn't signal, it doesn't transmit, it doesn't respond. It simply moves with precision, quietly, efficiently, indifferently. That indifference is what makes it terrifying. There's a quiet debate now among astrophysicists and data scientists, not about what 3i Atlas is, but about what it doesn't do. If it's engineered, why hasn't it communicated? Why remain silent after exposure, after heating, after everything it's endured? One unsettling theory proposes that communication isn't its function, that we're not the audience. Maybe the sequence we witnessed wasn't an activation, but a recording, a process triggered automatically when it reached a specific threshold of solar radiation, a routine check, not a reaction. Something ancient running through protocols written long before our star ever formed. Others think the timing might be environmental, that the object's 11-second pulse corresponds not to its own system, but to something in the sun's electromagnetic field that we simply don't understand. That 3i Atlas isn't sending, it's listening. Every explanation fractures under the same paradox. The more ordered the data, the less it resembles chance. There's also the possibility, quiet but persistent, that 3i Atlas isn't alone. If this pattern represents a design, then perhaps it's a standard, a template. And if that's true, then others like it may have already passed through, unnoticed, too faint or too brief to register. After all, Oumuamua exhibited non-gravitational acceleration. Borisov, though natural, showed composition inconsistencies. Now 3i Atlas adds synchronization, shielding, structure. 3 interstellar visitors, 3 impossible anomalies, each stranger than the last. And now, after Perihelion, 3i Atlas is leaving us, its signal fading, its reflection dimming, but not in decay. It's stable, organized, still pulsing every 11 seconds as it crosses the threshold where the sun's light begins to fail. In the deep archives of one observatory, an anonymous analyst left a single line in his notes. If this was maintenance, the next sequence won't happen here. It will happen wherever it's going. No one knows when or if we'll ever see it again. But those who followed it from the beginning, who've traced its anomalies line by line, understand that what the sun revealed was never chaos. It was function. It's November 3rd. The object is now almost 20 million kilometers past its closest solar approach. To the naked eye, it's just a dim trace in the dark. Magnitude 16, sliding slowly outward across the plane of the ecliptic. But for the scientists who followed it from the beginning, 3i Atlas hasn't faded. It's deepened. What's left now is not just data, but silence. A window that still hasn't closed. The agencies call it the post-perihelion observation phase. But inside that phrase lies a quiet admission. They're waiting for something. The last confirmed radar ping came hours ago, still showing that faint second echo, still locked in formation. But since then, there's been no official update. Not from NASA, not from ESA, not from anyone. Every major observatory has gone back to routine operations, pointing elsewhere, as though the object had finished its story. Yet behind closed doors, analysts continue to run fresh models every few hours. What they're watching isn't the orbit anymore, it's the timing. The 11-second pulse hasn't stopped. Even as the object dims, the modulation continues, steady, precise, unwavering. It has now persisted across every measurable domain: light, magnetism, thermal emission, and radar reflectivity. It has never varied by more than 2 milliseconds. That consistency defies thermal expansion, radiation pressure, or spin instability. It's not the beat of rotation, it's the precision of intent. Some scientists now describe the pulse as a metronome, a stable reference signal that could, in theory, serve as a clock for internal systems. Others believe it's a natural resonance within the object's metallic lattice. Both theories agree on one fact: the signal hasn't decayed. Whatever mechanism sustains it is self-correcting. That persistence is the unanswered window, the thing left hanging in every conversation, every late-night conference call between researchers who can't quite say what they believe. Because if the object's internal processes were purely thermal or chemical, they should have ceased days ago. The energy from the sun is gone, the heat has dispersed, and yet it still ticks. Independent teams continue to record faint oscillations across multiple frequencies, a heartbeat that won't fade. It's subtle, like the echo of a signal that refuses to die. But some have noticed another shift. The amplitude of the rhythm is decreasing slightly while its precision sharpens. It's as if the system is slowing down, cooling, conserving energy, entering another state. If the perihelion sequence was activation, this could be dormancy. The astrophysicists at the European Southern Observatory mapped the timing intervals against the object's position and found something haunting. Every time 3i Atlas crosses a defined solar longitude, the same geometric arc measured from the sun, the pulse amplitude dips, then recovers. It's reacting to position, as if its behaviour depends not on temperature or radiation, but on angle, orientation relative to the sun. It's still responding to something, and yet the agencies don't comment. Official statements have stopped altogether. Data is now routed through classified relay channels, leaving independent observatories to fill the silence. But those smaller instruments don't have the sensitivity to see what's happening in the object's internal structure. They only see the rhythm, the fading glow, and the echo of something deliberate moving away. A few researchers still try to explain it through physics: residual resonance, delayed electron alignment, charge retention in metallic crystals. They build models that account for everything except the precision. The math always drifts after a few cycles. The real object never does. One scientist described it best. It behaves like a clock that refuses to wind down. There's another theory, whispered but not written, that the window hasn't closed because it isn't supposed to, that the Perihelion sequence was never meant to end within our view. Perhaps it was only one half of a process, a trigger waiting for the next condition, somewhere farther out, where the sun's influence wanes. If that's true, then 3i Atlas is not finished. It's just between phases. The question that haunts the researchers now is where the next window will open. If the rhythm continues, it may align with another gravitational body, perhaps Jupiter's orbit, perhaps interstellar space itself. Whatever happens next will happen beyond our reach. And that is what unsettles everyone most. The knowledge that we've witnessed only a fraction of something. A system unfolding in slow motion across cosmic time, indifferent to our observation. The agency's silence has become part of the pattern now, the final stage of the sequence. Every previous anomaly was followed by a blackout, every revelation followed by quiet. It's as though the phenomenon extends not only into data, but into the behavior of those who observe it. For now, all we have is the rhythm. Every 11 seconds, somewhere in the cold beyond Mercury's orbit, a pulse still beats. Not strong, not bright, but exact. It's a reminder. Not of communication, but of persistence. The kind of persistence that doesn't seek attention, only continuation. And so the window remains open, not in time but in understanding. And the story of 3i Atlas now recedes into darkness. It no longer dazzles against the sun, no longer fills instruments with surges of heat and static. What remains is distance, an object vanishing from our sky, leaving only its rhythm behind. For weeks, the world has tried to reduce that rhythm to data points. 11 seconds between each pulse, 9 cycles per blackout, 43 minutes of silence. Numbers, patterns, models. But somewhere beyond the mathematics lies something harder to quantify. A quiet recognition that we may have witnessed a form of order without origin. If it is natural, then nature is capable of precision that mirrors intention. If it is not, then something once capable of intention has crossed our star, gone unseen for most of history and kept moving. The sun stripped 3i Atlas bare, burned away whatever shielded it, exposed the geometry beneath, and when the light faded, what survived was not ruin, but control. That single fact unsettles every equation we trust. It suggests endurance, the kind that isn't random. There are still arguments, still papers being written and retracted, still silence from those who know more than they will say. Yet under all of it, the same truth keeps returning. The object behaved as though it knew how to survive its encounter. Tonight, as it drifts beyond the reach of our telescopes, there's no flash, no farewell signal, just the faint invisible echo of a process still unfolding somewhere in the dark. Maybe it will never reveal itself again. Maybe it will sleep for another age. Or maybe, one day, another star will wake it, and another civilization will stand where we stand now, staring into its glow, wondering if what they're seeing is alive. Until then, the only thing we can say for certain is that the sun exposed something unexpected, and that it looked back briefly before disappearing.